In the automotive coatings industry, RD&I engineers are evaluated not only for their technical knowledge, but also for their ability to translate formulation science into production-ready, OEM-compliant coatings. OEMs expect engineers to operate at the intersection of chemistry, physics, application technology, and process engineering, demonstrating system-level thinking and practical problem-solving. System-level thinking is the cornerstone of evaluation. An effective coatings engineer understands that a coating is not a single layer, but a stacked system comprising pretreatment, primer, basecoat, and clearcoat. Each layer interacts chemically, physically, and mechanically with adjacent layers, and even minor changes in one layer can propagate through the stack, affecting adhesion, appearance, and durability. OEMs assess whether engineers can predict system behavior, identify interlayer sensitivities, and design formulations that are robust across all layers and process conditions. Failure analysis capability is another critical criterion. OEMs evaluate whether an engineer can diagnose defects such as sagging, solvent popping, mottling, orange peel, adhesion loss, or shade variation, and determine root causes through logical, data-driven approaches. This requires not only knowledge of chemistry and material science, but also a strong understanding of process variables, equipment limitations, and environmental effects. Engineers must demonstrate the ability to connect laboratory observations to production realities and recommend actionable solutions. Production awareness is essential. Coatings that work perfectly on lab panels can fail on full vehicle bodies due to geometry, thermal mass, airflow patterns, and operator variability. OEMs expect engineers to anticipate production challenges, design experiments that mimic real-world conditions, and interpret data within the context of manufacturing tolerances. Understanding process windows, DFT variation, solvent evaporation profiles, and oven curing dynamics is critical to prevent costly production defects. Decision-making under uncertainty is also evaluated. OEMs look for engineers who can weigh formulation constraints, production variability, and risk factors to make technically sound, practical recommendations. This includes prioritizing defect mitigation, balancing performance with manufacturability, and designing coatings that maintain performance across environmental and operational extremes. Documentation and communication skills are equally important. Engineers must provide clear, evidence-based reports on experiments, failures, and corrective actions. Data should support conclusions, and recommendations must be actionable for cross-functional teams, including production, quality, and design engineers. In summary, OEMs evaluate coatings RD&I engineers on system-level understanding, failure analysis capability, production awareness, technical decision-making, and effective communication. Success requires combining deep technical knowledge with practical insights into how coatings behave in the real-world manufacturing environment. Engineers who can anticipate challenges, diagnose root causes, and implement robust solutions are valued as essential contributors to OEM coating quality and reliability. If you have technical questions related to coatings RD&I responsibilities, failure analysis techniques, system-level design, or production-aware formulation strategies, share them in the comments for discussion in future episodes.